This is problem 636, and we'll do it using Laplace transforms. So we have our circuit here, and as always with Laplace transforms, we need to find IL of 0 minus, which is the same as IL of 0, and VC of 0 minus, which is the same as VC of 0. We can tell that this is a parallel RLC circuit, and that'll help us decide how we want to do the transform. So it's been in position 1 for a long time, and so the area on the right side of the circuit over here, this is all open, and so there's no current running through the inductor. So IL of 0, which is the same as IL of 0 minus, is 0. Now, over on the left-hand side of the circuit, if it's been in position 1, then the capacitor will be an open circuit, and no current will flow, and so the top side will be at 12 volts and the bottom side will be at 0 volts if we call this ground. Either way, the voltage across the capacitor, VC of 0 minus, equals VC of 0, equals 12 volts. Okay, so now let's look at what it looks like at time t equals 0. So we're connected here, and we've got a capacitor and a resistor in parallel. So we will transform this to the S domain, and let's take a look at the transforms that we want to do if we're in parallel. So when we're in parallel, a capacitor can go to a capacitor and a current source in parallel, and the capacitor will be, the impedance will be 1 over SC, and the current source will be CVC. And here's what the inductor would look like if we change it to being in parallel. So CVC and 1 over SC, right, yeah, okay. So let's go back and transform our current into the S domain. So our capacitor will turn into a capacitor and a current source in parallel. And the current source is CVC, and CVC of 0. And the capacitance is 0.1, and VC of 0 is 12. So then the current is 1.2. And the capacitor gets transformed into 1 over CS. C is 0.1, so 1 over 0.1 S. 1 over 0.1 is 10, so that's 10 over S. So the impedance here is 10 over S. And then we have a resistor, and the resistor will just be 2. And then we have an inductor. Now IL of 0 is 0, so we don't have to put a current source in parallel. And the inductor will be LS. L is 10/6, so this will be 10/6 S. Now we can see that IC has to equal, I'm sorry, not IC, I from the current source. I drew that the wrong way. So if this was the capacitor, I should have drawn it going this way. And so we can see that the current here has to equal IC plus IR plus IL. Now, the way impedances work is that V equals I of S times Z of S. So it's just like V equals IR in the time domain. And so I equals V over Z of S. So this current right here, 1.2, has to equal, I'll just write it quickly as V over R plus V over SL plus VSC. So just writing it, these are the reciprocals of the impedances right here. So this becomes 1.2 equals, and factor out a V, and 1 over R is 1/2, plus 1 over SL, if I can read my writing, is 1 over S times 6 over 10. So just the reciprocal of that, plus 0.1 S, so the reciprocal of 10S is 0.1 S. And I'm sorry, my S's look just like my 5's. Then we also, we're going to start by finding IC. So if you just look at IC, we can see that V has to equal IC times 10 over S. So I times Z. So V, well, I've got it here, V equals 10 IC over S. So I can write this now as 1.2 equals 10 IC over S times 1/2 plus 1 over S times, and I'll just reduce that to, well, actually it'll be fine to have it as 6/10, plus 0.1 S. Now we're going to want to get all S's out of the denominator, and we're going to want to have our quadratic term having a 1 in front of it. Now if we multiply this 10 through here, and we're later going to have a quadratic term, then that will get us what we need. Let's see. So I am going to multiply both sides by S, so 1.2S, and so this S will cancel, and I'll multiply this 10 through here, so I get 10 over 2 is 5, plus 6 over S, plus S. Now I want to get rid of this S, so I'll multiply both sides by S again, and I get 1.2 S squared equals 5S plus 6 plus S squared. what happened to my IC? Here it is, IC. So IC equals 1.2 s squared over s squared plus 5s plus 6, and that factors so that we get s squared over s plus 3 times s plus 2. So now we need to do partial fractions. Let's see, I messed up somewhere. No, I think it's my notes that are wrong. So we need to transform or change this using partial fractions. So s squared over s plus 3 times s plus 2 equals a over s plus 3 plus b over s plus 2. Now I'm going to show you my super sneaky way of doing partial fractions as long as you just have linear factors. So if you just have linear factors, to figure out the a, you look at the denominator here, s plus 3, and you figure out what s would make that equal to 0, and that would be negative 3. So I take negative 3 and I plug it in to my original fraction, but not using s plus 3. So that would give me 9 over negative 1, which is negative 9. And so the a is now negative 9. So this is now negative 9 over s plus 3. Now to find out what b is, I do the same thing. What would make this equal to 0 is negative 2. So I plug negative 2 into this except for the s plus 2 term, and that would be 4 over 1, or 4. So my b term is 4 over s plus 2. So that tells me that now I can say that IC equals 1.2 times negative 9 over s plus 3 plus 4 over s plus 2. Now to find IC in the time domain, these are really easy to take the inverse Laplace transform. So IC in the time domain is 1.2 times negative 9 e to the negative 3 plus 4e to the negative 2. So that's IC. Now the problem also asks us to find IL, and so I'm going to go back to right here, V equals 10 IC over S, and so this V, these are all in parallel, so they all have the same V, and so I can say that V equals IL times 10 over 6 S, just V equals IZ, so I and Z. Now I know that V equals 10 IC over S equals IL times 10 over 6 S. Now IC over here equals, well, actually let's use this one. So, and also, well, let's cancel out our 10s, and let's bring the s, divide both sides by s squared. So I have IC over s squared equals IL. Now this was IC, and oh, I forgot my 6. So let's multiply by 6. So 6 times 1.2 s squared over s plus 3 times s plus 2, and there's also an s squared here, so there's an s squared from here, and there's an s squared from our IC, equals IL. So our s squareds cancel, and 6 times 1.2 is 7.2. Now over here I have, let's write this right here, so I have 1 over s plus 3 times s plus 2. That equals a over s plus 3 plus b over s plus 2. To figure out a, I'm going to plug negative 3 into this without the s plus 3. So negative 3 is 1 over negative 3 plus 2. That's negative 1. So this is negative 1 over s plus 3. Now to figure out b, I'll plug negative 2 into here, and I get 1 over 1, which is 1. So b is 1 over s plus 2. So now I can write this fraction, I can write the partial fraction as negative 1 over s plus 3 plus 1 over s plus 2 equals IL. Now that's another one that's easy to take the inverse Laplace transform of. So that's just going to be IL equals 7.2 times negative e to the negative 3t. Oh my goodness, look, I left the t's out. T, e to the negative 3t plus e to the 2t. Let me write that a little neater over here. Just trying to get it to fit all on one page. If we print it, IL equals 7.2 e to the negative 3t plus e to the negative 2t. And that's IL. And this was IC with the t's. I'm sorry, I forgot the t's earlier. And that's problem 636.